Hi, my name is Muhammad Zubair bin Bahak, and in this video we will discuss in detail how we solve a problem related to manometer. Okay, and this is example 2.4 according to your slide. Okay, so the question is find the pressure difference between point A and point B. So let's assume the benzene having the specific gravity of 0.877 and kerosene is 0.82. Okay, so now we try to determine what is the pressure difference between these 2 points. Okay, so the first thing you need to do is to draw the free body diagram or simple manometer, and then the second step is to you need to decide which way you want to come. All right, whether you come from A to B, or in other words from left to the right, or from the right to the left. Okay, so first what you need to do now is to determine the a point. Okay, so on every surface of the fluid you put it as a point. So I cross it here. All right, so let me see if I can cross it there. Okay, so I cross it here as a point 1. All right, cross it. This is 1 point, and I think I better take a blue color here. All right, so I got the clue blue there. That's 1 point. This another point. This another point, and this also another point. Okay, so if you decide from left to the right, so we call the point A here, all right, as a point 1, and over here as a point 2. Here is a point 3, over here as point 4, this is a point 5, and B as a point 6. Okay, and one more thing is that if you see at a point 2 at the bottom here, all right, if you can see a point 2 at the bottom here, okay, you see on the left and on the right side, okay, both on the same fluid and on the same level. So the red line here is also a point 2. It is also the same with the point 4 here, all right, on the same fluid, on the same level. So this actually is point 4, and also at the point 5 here, all right, because on the same fluid in the same level, so D is a point. This is a point 5. Okay, so with all the data that you have there, so now I think it's time for us to do the calculation. All right, to do the calculation. Okay, so we start with the dp dp dz. All right, so dp dz is equal to okay, dp dz is equal to minus rho g. All right, that the base equation. All right, the basic equation, and then we start from 1 to point 2. All right, as a guidance. So we say, okay, from point 1 to point 2, you write as a P2 is equal to P1. All right, and then now from 1 to 2, actually you are going down. All right, so when you're going down, it means the pressure will increase. And how much is it increase? Depend on the what type of fluid that we have there, which is a rho benzene time the G and time the distance or the height of the fluid, which is 0.2 meter. Okay, so that a point 2. Next we have this P, from 2 you go to point 3, P3 is equal to P2, and now you are going up. All right, from 2 to 3 you are going up. All right, so minus the fluid, which is rho mercury, all right, time the G and time the distance, which is 0.08. And then after that you have this P4. All right, P4 is equal to P3, and if you look into the figure there, your 3 to 4 actually is you moving up. All right, going up again. So you lost the pressure. All right, so how much you lost? It is a rho of the kerosene time the G and time the distance, which is 0.4. All right, minus this 0.08. Okay, and next after that you have this P5. All right, P5 is equal to, Okay, see, I can bring it down here. Cut this one. Okay, and then you have this P5 is equal to P4. Alright, from 4 to 5 you are going down, so plus, and the fluid is water, rho g, and the distance is 0.4 minus 0.14. Okay, and 5 and 6, which is air in a confined place. Alright, so when you have air in a confined place, so the pressure are the same in anywhere within that confined place. Okay, so in other words, we can say P6 is equal to P5. Okay, and now we have one equation, two equation, and we got 3 there, and finally we have 4 equation. All right, so we take 1, 2 and 3 and put all together into the fourth equation, and you have the P6 is equal to your P1 plus the rho benzene times the G times 0.2, and then minus your rho Hg times the G, and then 0.08, and then minus the rho kerosene time G, all right, and then time the distance, which is 0.320, and then plus the rho of water, and the distance is equal to 0.260. Okay, and once again, in this case, we don't have the value of rho b, and we don't have the rho q, rho k and rho hg. Okay, but we know the hg of a fluid is equal to rho of the fluid divided by rho of water. So in other words, density of benzene is equal to Sg of the benzene times the rho H2O. Okay, so take this equation and put back into our original equation, and finally you have the P6 is equal to your P1, and then plus this benzene having the Sg of 0.87, and then time the rho g of water times 0.2 minus the mercury 13.6, rho g times 0.08, and then minus the kerosene, which is 0.82 times rho g times 0.320, and then plus the rho g of water times 0.260. Okay, and rearrange the equation, you will have the P6 minus P1 is equal to, and all the term in the on the left right side having the rho g. All right, so we put the rho g outside and left us with 0.877 times 0.2 minus 13.6 times 0.08 minus 0.82 times 0.320 and plus 0.260. Okay, and you know the value of this rho g is actually is 9810. All right, so don't forget that. Okay, so this rho g in this case, right, our rho g is 9810. All right, so having all the value there, finally you have your P6 minus P1. All right, P6 minus P1 is equal to minus 8.98 kilopascal, or we can say it's almost like minus 9 kilopascal. Okay, but the question asks us to determine the PA minus PB, or in other words P1 minus P6. So P1 minus P6 is equal to 9 kilopascal. Okay, so that's how we solve a problem related to manometer, which I show you step by step. All right, the first thing you need to do is to cross all the surfaces. All right, and then after that you need to decide whether you come from left to the right or from the right to the left. Okay, and then you keep on moving from one point to another point until you reach the final point. Okay, so I think with that we stop here, and I'll see you back with another example.